Hello students, welcome to another video. Today we will be solving Pure Maths Paper 1 from May-Jun 2017, Variant 11. Now let's look into the first question. Question number 1, it says the coefficients of x square and x cube in the expansion of 3 minus 2x to the power 6 are a and b respectively. Find the value of a over v. So 3 minus 2x to the power 6. So in order to get the coefficient of x square, we need 6c2 because this 2 will be the power of 2x whole square. Eventually we will get x square. So 6c2, then this will be 3 to the power 6 minus 2 and 2x whole square. 6c2 will be 15, 3 to the power 4 will be 81 and 2x whole square will be 4x square, which gives us 4860 x square. In order to get the coefficient of x cube, we require 6c3. So this will be 3 to the power 6 minus 3 and this will be 2x to the power 3. So that will give you 20 times 27 times 8x cube, which will be 4320 x cube. Therefore, since the coefficient of x square is a, that means a is 4860, similarly b will be 4320. And they are asking us to find the value of a over b. That means a over b should be 4860 over 4320. Simplifying it further will give us 9 over 8. Question number 2 is not in the syllabus at the moment. Question number 3, it says prove the identity 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta, which is equivalent to 2 over sin theta. So in order to do the LCM, we take the product of these two, which will be sin theta times 1 plus cos theta, and then we cross multiply 1 plus cos theta with 1 plus cos theta and sin theta with sin theta, which gives us 1 plus cos theta whole square plus sin theta whole square. 1 plus cos theta whole square will be 1 plus 2 cos theta plus cos squared theta, and this will be sin squared theta. Then we can say that sin squared theta plus cos squared theta is equal to 1, and we have 1 plus 2 cos theta on the left hand side. And simplifying it further, 1 plus 1 will become 2, and then we have 2 cos theta. Now if we take 2 common, this will be 1 plus cos theta. So we can cancel these two and we will be left with 2 over sin theta, which is equal to the right hand side. In part 2, it says, hence solve the equation 1 plus cos theta over sin theta plus sin theta over 1 plus cos theta equals to 3 over cos theta. We have already found that the equation on the left hand side can be written as 2 over sin theta. So we can say that 2 over sin theta is equals to 3 over cos theta. So if we cross multiply, we will get 2 over 3 is equal to sin theta by cos theta. The reason we did that so that we can have this as tan theta. So sin theta by cos theta is tan theta. That means tan theta is equals to 2 over 3. Now let's find the basic angle first. So basic angle alpha is equals to tan inverse of 2 over 3. That will give us alpha 33.69 degrees. That is the basic angle. And since this is positive, that means tan theta lies in the first quadrant and the third quadrant. And the limit that we have for this question is between 0 to 360. So theta should be, the basic angle is the actual angle, and 180 plus the basic angle. That will give us 213.69. That means if we correct it to 3 significant figures, it will be 33.7 and 213.7 degrees. Question number 4, it says an arithmetic progression has a first term of 32, a fifth term of 22, and a last term of negative 28. Find the sum of all the terms in the progression. So first term a is 32, and fifth term means a plus 4d is equals to 22. Now also last term is equal to negative 28. We know the value of a is 32, so we can write it as 32 plus 4d equals to 22. That means 4d is equal to negative 10, so 22 minus 32 will give you negative 10. That means d should be negative 10 over 4. Simplifying it, we will get d is equals to negative 5 by 2. Now for the last term, we know the last term is negative 28 and a is 32. So a plus n minus 1 into d, where we know the value of d now. So negative 28 should be equal to 32 plus n minus 1 times negative 5 over 2. So that will give us negative 28 equals to 32 minus 5 by 2n, and negative negative will give you a positive, so positive 5 over 2. Now if I cross multiply 2 with negative 28, but before doing that I must multiply 32 with 2 as well, because there is no 2 in the denominator for the number 32. So that will give us 64, and 28 times 2 is negative 56. So now we are left with negative 56 is equals to 64 minus 5n plus 5. So 5n is equals to 64 plus 56 plus 5. So 5n will be 125. That means n is 25. So this is how we manage to find the number of terms in this progression, of which the last term is negative 28. But we are required to find the sum of all the terms in the progression. So sum of 25 terms should be 25 over 2 within brackets 2a plus n minus 1 times d, where a is 32 and d is negative 5 over 2. Simplifying it, we will get 25 over 2, and 32 times 2 is 64, minus this will give you 60. So sum of 25 terms should be 50. In part B, it says each year a school allocates a sum of money for the library. The amount allocated each year increases by 2.5% of the amount allocated the previous year. In 2005, the school allocated $2,000. Find the total amount allocated in the years 2005 to 2014 inclusive. So our first term is 2000, and since it increases by 2.5% each year, that means we have a geometric progression. So the common ratio should be 1.025, because when the amount increases, we have the original amount and an extra 2.5%. So 100% and 2.5%, when you convert this into decimals, it will give you 1.025. So the number of terms should be from 2014 minus 2005 plus 1, because 2014 is inclusive. So n should be 10. So sum of 10 terms for this situation should be a within brackets r to the power n minus 1 over r minus 1, which is 2000 within brackets 1.025 to the power 10 minus 1 and 1.025 minus 1. That will give you $22,406. Question number 5, it says the equation of a curve is y equals to 2 cos x. Sketch the graph of y equals to 2 cos x, and the limit is between negative pi and positive pi. Stating the coordinates of the points, coordinates of the point of intersection with the y-axis. So this is the grid for cos x, which is 1, 0, minus 1, 0. So when you multiply 2 with this grid, you will get 2 times 1 is 2, 2 times 0 is 0, and 2 times negative 1 is negative 2, and 2 times 0 is 0. So with the help of this grid, if we want to sketch now, it is easier to do that. So the maximum point, when it's 0 degree, it is the y-axis is 2. The y value is 2. When it is pi by 2, which is 90, it will be 0. And when it is 180, it is negative 2. And similarly, since we know the pattern of cos x, so in the negative side, if pi by 2 is giving us 0, similarly minus pi by 2 will also be 0, and minus pi will be minus 2. For part 2, it says points P and Q lie on the curve and have x coordinates pi by 3 and pi respectively. We need to find the length of PQ correct to 1 decimal place. So we know the equation of the curve, which is y equals to 2x. When x equals to pi by 3, y should be equals to 2 cos pi by 3. And if you know the trigonometry table, you should know that cos pi by 3 is half. So 2 times half will give you 1. And when x equals to pi, y is equals to minus 2, because cos pi should give you minus 1. So 2 times minus 1 is minus 2. So the length of PQ, we know the xy coordinates for P and Q. So the length of PQ should be root over x2 minus x1 whole square plus y2 minus y1 whole square. So pi minus pi by 3 whole square plus minus 2 minus 1 whole square. That will give you 3.7 units. Part 3 says the line through P and Q meets the x-axis at h, and the coordinate for h is h and 0, and the y-axis at k, and the coordinate for that is 0 and k. Show that h is equals to 5 pi over 9 and find the value of k. So this is the coordinate for p. We have found pi by 3 and 1, and q should be pi minus 2. Equation for the line PQ will be y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And this is the formula we use when we are provided with two coordinates. So with the help of this formula, we can form the equation of the line pretty easily. So simplifying it, we will get this pi minus pi by 3 will give you 2 pi by 3. So 2 pi by 3 will get multiplied with my y minus 1, and minus 2 minus 1 is minus 3. So minus 3 times x minus pi by 3. So at h, which is h0, we now have the equation of the line PQ. We simply need to substitute this coordinate in this equation, because this coordinate lies on the line. So this will give us negative 2 pi by 3 equals to minus 3h and plus pi. So 3h is equals to pi plus 2 pi by 3. So h should be 5 pi by 3 times 1 by 3, because pi plus 2 pi by 3 is 5 pi by 3. And if we cross multiply to have h as the subject, this will become 5 pi by 3 times 1 by 3. So that will give you h is equals to 5 pi by 9. Now for the point K, which has the coordinate 0k, again we simply substitute this x coordinate and y coordinate into the equation of the line PQ, because this point lies on this line. That will give us 2 pi by 3 k minus 1 equals minus 3 and 0 minus pi by 3. So 2 pi by 3 within brackets k minus 1 is equals to just pi. So k minus 1 should be pi times 3 over 2 pi. We simply cross multiply this fraction and we have the reciprocal over here. So k minus 1 is equal to 3 over 2. Therefore k should be equal to 3 over 2 plus 1. So k will be 5 over 2. Question number 6. The horizontal base of a solid prism is an equilateral triangle of side x centimeter. The sides of the prism are vertical. The height of the prism is 8 centimeter and the volume of the prism is 2000 centimeter cube. We need to express h in terms of x, and then we need to show that the total surface area of the prism, a centimeter square, is given by this equation. So this is a diagram for the question where we have a equilateral triangle as the base, and this will be the same at the top as well, and this is the height of the prism. So we know that volume of a prism is the cross-sectional area times the height. So the cross-sectional area for an equilateral triangle will be half AB sine theta, where if I consider it's already provided that the side of the triangle is x, so it will be half times x times sine 60, because the each interior angle of an equilateral triangle is 60 degrees. So that will give you half x square sine 60 and times the height. We know the volume, which is already provided in the question, and that is 2000. So 2000 is equal to x square, and this will become sine 60 is root 3 over 2. So root 3 over 2 times half will give you root 3 over 4 and times h. So if we make h the subject, it will be 8000 over x square root 3. Now, total surface area. So for the total surface area, we have two triangles, one at the top and one at the bottom. So that will be 2 times the area of each triangle, which is half AB sine theta, plus we have 3 rectangles on the sides. So where you need to multiply, since there are 3 of them, so length times breadth will be h times x. So this will become x square root 3 by 2. Sine 60 is root 3 by 2, and this 2 and this 2 will cancel out, and we will be left with x square times root 3 by 2. Plus, we are multiplying 3 with all the elements inside. So 3 times, we know that h can be rewritten as 8000 over x square root 3 and times x. So this will become x square root 3 by 2 plus 8 3 is a 24, so 24,000, and if we simplify x, the power of x, it will become x root 3. So the way you can understand why you need to substitute h is because what they have asked us to express, there is no h in the expression, so we must substitute h in terms of x, and that will help you to solve this question. Part 2 of the question says, given that x can vary, find the value of x for which a has a stationary value. So we found that a is root 3 over 2 x square plus 24,000 over root 3 x to the power minus 1. So since we're talking about stationary value, that means we need to find dA by dx. We need to differentiate this equation. Upon differentiating, this will become, if we multiply the power 2 with root 3 by 2, it will become just root 3, and 2 minus 1 is just 1. And 24,000 over root 3, and then we have x to the power minus 1. So if we multiply minus 1 with the 24,000 over root 3, it will give you negative 24,000 over root 3. And minus 1 will give you minus 2. So simplifying it, we can rewrite it as root 3x minus 24,000 over root 3x positive square. So if we do LCM, we will get root 3x square in the denominator, and we need to multiply root 3x square with root 3x since there is nothing in the denominator. So that will give you 3x cubed minus 24,000. Now, at stationary point, we know that dA by dx should be 0. That means 3x cubed minus 24,000 over root 3x square is equals to 0. So cross multiplying it will give us 3x cubed minus 24,000 equals to 0. Or we can say 3x cubed is equals to 24,000. Therefore, x should be 20. For part 3, it says determine, showing all necessary working, the nature of this stationary value. So since it's a bit complicated, or I should say it's not feasible to double differentiate this equation to obtain the nature of the stationary value, what you can also do is take a value, at least one value before and one value after, of which you got the turning point, which is the stationary value. So we got the stationary value when x is equals to 20. So one value before it is 19. So I'm substituting x equals to 19 in dA by dx, and I'm getting that dA by dx is negative 5.47. And when I'm taking one value more than the value 20, which is 21, and if I substitute it in dA by dx, I'll be getting dA by dx is equals to 4.95. So since the gradient shifts from negative to positive, that means it is a minimum point. Question number 7. A curve for which dy by dx is equals to 7 minus x square minus 6x passes through the point 3 and negative 10. We need to find the equation of the curve. So first we need to integrate this. So integrating 7 minus x square minus 6x will give us 7x, and this will become 2 plus 1, 3, and this will be 1 over 3, minus x to the power 1 over here. So 1 plus 1 will be 2, and 6 divided by 2 will be 3, plus c. So with the help of this coordinate, we can find the value of c, the constant. So we can write y is minus 10 and x will be 3. So that will give us minus 10 is equals to 21 minus 9 minus 27 plus c. So c should be 5. So the equation of the curve must be y equals to 7x minus 1/3 of x cubed minus 3x squared plus 5. In part 2, it says express 7 minus x squared minus 6x in the form of a minus x plus b whole square, where a and b are constants. Now you need to understand that this is the completed square form. So in order to express this in this form, first we need to fix the equation. We can write it as minus x square minus 6x plus 7. And we can take minus common, and this will become x square plus 6x within brackets and plus 7 on the outside. Now the completing square will take effect only within this. So we still have minus on the outside, and this will be x plus 3 whole square. 6 divided by 2 is 3. So x plus 3 whole square minus 3 whole square, and second bracket close, plus 7. So then we will be having minus x plus 3 whole square minus 3 square is 9. Make sure that you are using appropriate brackets, because if you don't use brackets appropriately, then the values will get affected. So now since we are done with the squaring these, now we can take away the brackets outside and multiply with negative with all the elements inside. So minus times x plus 3 whole square will be minus x plus 3 whole square, and minus minus will become plus, and this is 9 plus 7. So minus x plus 3 whole square plus 9 plus 7 is 16. Or we can write it as 16 minus x plus 3 whole square. So now you can see that it has taken the form of this equation. So therefore, we can also understand that a is 16 and b is 3. In part 3, it says find the set of values of x for which the gradient of the curve is positive. So 16 minus x plus 3 whole square is greater than 0 because they're stating that we need to find the set of values of x for which the gradient is positive. So we can write this equation as 4 square minus x plus 3 whole square greater than 0. And you might notice that this has taken a form of a square minus b square. And we know that a square minus b square is a plus b, a minus b. So this can be written as 4 plus x plus 3 and 4 minus x plus 3. So if we simplify this, this will become 4 plus x plus 3 and this will become 4 minus x minus 3. So this should give you x plus 7 and this should give you 1 minus x. And all of them are greater than 0. So the critical values for this equation are x equals to negative 7 and x equals to positive 1. So as you can see that this quadratic equation, if you expand it, or if you look into the original equation, you can see that it is a negative quadratic equation. By multiplying x with negative x, you will get a negative quadratic equation. And we know that the negative quadratic equation will take this shape of the curve. So having minus 7 on the left hand side and 1 on the right hand side, and also at the same time we need to find the values for which it will be greater than 0. So greater than 0 lies over here. This part of the curve is greater than 0. So since this part is greater than 0, that means x lies between minus 7 and 1. Question number 8. In the diagram, OAXB is a sector of a circle with center O and radius 10. The length of the chord AB is 12. The line OX passes through M. The midpoint of AB and OX is perpendicular to AB. The shaded region is bounded by the chord AB and by the arc of a circle with center X and the radius XA. We need to show that the angle AXB, this whole angle AXB, is 2.498 radians corrected to 3 decimal places. So in order to solve this, what we can do first is in triangle AMO, OM, this length OM should be equal to square root of 10 square minus 6 square, because AMO is a right angle triangle, and OA is also 10 because this is 10, this should also be 10. And since AB is 12, that means this is 6 because M is at the midpoint. So that will give us OM is 8 centimeters. So XM equals OX minus OM, which is this part. XM is OX minus OM. Therefore, XM should be equal to 10 minus 8. 10 was the radius. As you can see that if this is 10, then OA is also 10. Also, OX is also 10 because these are all the radius. So 10 minus 8 will give us 2. Now in triangle AXM, this triangle, just this triangle, we know the value of XM now, which is 2, and we know the value of AM as well, which is 6. In order to find this angle, we can see that this is also a right angle triangle. So we can definitely use SOHCAHTOA. So 10 AXM will be opposite by adjacent. So opposite is 6 and adjacent we just found is 2. So 10 AXM should be equals to 3. Therefore AXM is 10 inverse of 3. Therefore AXB, which is the angle that we are required to find, should be 2 times of 10 inverse of 3. So AXB will be 2.498. In part 2, it says find the perimeter of the shaded region. So that means we need to find this perimeter. So we already know the value of AB. We just need to find this arc length AB, for which the center is X. So in triangle AXM, AX is equals to square root of 6 square plus 2 square. In triangle AXM, AX is equals to 6 square plus 2 square root of. Because for this triangle, the right angle is over here. That means AX is the hypotenuse. So that will give us AX is 2 root 10. Therefore, arc AB will be r theta, where r is the radius. So the radius AX is 2 root 10. And theta in radians we just found is 2.4980915. So that will give us 15.799. So the required perimeter should be the arc, which is this 15.8, plus the 12, which is this. And that will give you 27.8. In part 3, it says find the area of the shaded region. So area of the shaded region will be half r square theta minus sine theta, because this is the formula that we use when we are asked to find the area of the minor segment, and if we have the degrees, if we have the angle in radians. So we found that the radius is 2 root 10, which was this AX. If we take X to be the center, and we are required to find this shaded region, so this is the minor segment, and the formula that I just stated, that area of the minor segment, if the angle is in radians, should be half r square theta minus sine theta. We know the angle and we know the radius as well. So this will be half r square, which is 2 root 10 whole square. Theta is 2.4980915 minus sine theta. And that will give you 38 unit square. Question number 9 says that the function f is defined by f of x is 2 over 3 minus 2x, where x is an element of all the real values, but x is not equal to 3 over 2. We need to find the expression for f inverse of x. So let's consider y is equals to f of x. That means y is equals to 2 over 3 minus 2x. Or we can say 3 minus 2x is equals to 2 over y. So minus 2x is equal to 2 over y minus 3. If we multiply negative 1 on both sides, then we will get 2x is equals to 3 minus 2y. So 2x should be 3y minus 2 by y if we do the LCM for this. So this will be 3y minus 2 over y. That means x will be 3y minus 2 over 2y. Now f inverse of y is equals to x, or we can say f inverse of y is 3y minus 2 by 2y. So f inverse of x should be 3x minus 2 over 2x. Or we can split this and write it as f inverse of x is equals to 3 over 2 minus 1 over x. The second part of the question says the function g is defined by g of x is equal to 4x plus a for all for x is an element of all the real values where a is a constant. Find the value of a for which gf of minus 1 is equals to 3. We know that f of x is 2 over 3 minus 2x and g of x is equals to 4x plus a. So the composite function should be 4, and f of x will be substituted in x. So this will become 4 and then within brackets 2 over 3 minus 2x plus a. We are provided with that gf of minus 1 is equals to 3. That means 4 and 2 over 3 minus 2 within brackets minus 1 plus a is equals to 3. So simplifying it, we will get 8 over 5 plus a equals to 3. Or we can say that 8 plus 5a equals to 15. So how did this happen? So I cross multiplied 5 with 3, but before doing that, I made sure that I have multiplied a with 5 before cross multiplying 5 with 3. So 8 plus 5a is equals to 15. Therefore 5a should be 7. That means a is 7 over 5. In part 3, it says find the possible values of a given that equation f inverse of x equals to g inverse of x has two equal roots. So we have found f inverse of x. Now let's look into g inverse of x. So y is equals to g of x. So y is equals to 4x plus a. Or we can say 4x is equals to y minus a. Therefore x will be y minus a over 4. That means g inverse of y is x. So we can say g inverse of y is equals to y minus a over 4. Therefore, g inverse of x should be x minus a over 4. And we already know that f inverse of x is 3x minus 2 over 2x. According to the question, f inverse of x is equals to g inverse of x. Therefore, 3x minus 2 over 2x is equals to x minus a over 4. If we cross multiply, we will get 12x minus 8 is equals to 2x square minus 2ax. So, this will become minus 2x square plus 12x plus 2ax minus 8 is equals to 0. If we multiply with negative 1 on both sides, we will get 2x square minus 12x minus 2ax plus 8 is equals to 0. So, let's now convert this equation in the form of ax square plus bx plus c. So this will become 2x square plus, I'm taking all the coefficients of x common. So this will be minus 12 minus 2a, and this will be the constant. So since it says that we need to find the possible values of a for which it has two equal roots, that means b square minus 4ac should be equal to 0. So this is our b, which is minus 12 minus 2a whole square, minus 4ac, where a is 2 and c is 8. So that will give us 4 to the 8, 8 is the 64, and this will become minus 12 minus 2a whole square equals to positive 64. So if we square root both sides, we will get minus 12 minus 2a is equals to plus minus 8. So 2a should be minus 12 plus minus 8. So a will be minus 6 plus minus 4. This is done by dividing both sides with positive 2. Therefore, a will be either negative 10 and minus 2. Question number 10. It says the diagram shows part of the curve y equals to 4 over 5 minus 3x. Find the equation of the normal to the curve at the point where x equals to 1 in the form y equals to mx plus c, where m and c are constants. So we have this equation y equals to 4 over 5 minus 3x, or we can write it as 4 times 5 minus 3x to the power minus 1. That will help us to differentiate this equation easily. So dy by dx will be minus 1 times 4 is negative 4, and then the outside differentiation will be 5 minus 3x to the power minus 1 will give you minus 2, and inside differentiation will give you negative 3. So simplifying this will give us negative 4 and negative 3 will give us positive 12, and this will be 5 minus 3x to the power positive 2. So when x equals to 1, because we need to find the equation of the normal to the curve at the point where x equals to 1. So dy by dx is the equation for the gradient. So when x equals to 1, this will be 12 over 5 minus 3 whole square. And that will give you that the gradient when x equals to 1 is 3. Also, we need to find the y coordinate when x equals to 1. So y should be 4 over 5 minus 3. That will give us y is equals to 2. Now we have the gradient. Also, we have the x and y coordinate. But the gradient that we have is for the tangent. When we differentiate y, we get the equation of the gradient for the tangent of the curve. So that means the gradient of the normal if the gradient of the tangent is 3, the gradient of the normal should be minus 1 by 3. Therefore, equation of the normal should be y minus y1 equals mx minus x1, which is y minus 2 equals minus 1/3 within brackets x minus 1. So cross multiplying it, we will get 3y minus 6 is equals to negative x plus 1. So 3y is equals to negative x plus 7. So I'm writing this in the form of y equals to mx plus c. So that will give us y is equals to negative 1/3 of x plus 7 by 3. In part 2, it says the shaded region is bounded by the curve, the coordinate x's, and the line x equals to 1. We need to find, showing all necessary working, the volume obtained when this shaded region is rotated through 360 degree about the x-axis. So since we are talking about the volume, we need to, and it is rotated about the x-axis, so we need to find the equation for y square. So y is 4 over 5 minus 3x, so y square should be 16 over 5 minus 3x whole square. Or we can write it as y square is equals to 16 and within brackets 5 minus 3x to the power negative 2. In order to find the volume should be equal to pi, and we need to integrate with the limits 1 and 0. Let's look into the diagram again. So we have 1 and 0. And we need to integrate y square. So this will be pi and integration of limits 1, 0, 16, 5 minus 3x to the power minus 2. So if we take all the constants outside, this will be 16 pi, and then we were left with integrating 5 minus 3x to the power minus 2. If power is the operator, we need to differentiate this. So differentiating 5 minus 3x will give us negative 3. So we bring negative 3 over here, and in order to balance it, we multiply on the outside with 1 by minus 3. Now this will become 16 pi times negative 1 by 3 and 5 minus 3x minus 2 plus 1 will give you minus 1, and so this will be 5 minus 3x to the power minus 1 over minus 1. So negative negative will become positive, so this will become negative negative will cancel out, and we are left with 1 over 3 times 5 minus 3x if we bring 5 minus 3x to the power minus 1 in the denominator, and the limits that we have is 1 and 0. So 16 pi, then we have 1 over 3 5s are 15 and 3 3s are 9x. So substituting 1 and 0 into this equation, this will give us 1 over 15 minus 9 minus 1 over 15 minus 0. So that will be 1 over 6 minus 1 over 15, which is 1 over 10. So 16 pi times 1 over 10 will give us 16 pi over 10, which is 8 pi over 5. And that will be all for now. I will see you in the next video.